Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So I was doing O-level past papers and I've started IGCSE Chemistry 0620 and I'm done with paper 41. This time I've selected paper 42 and it's of October-November 2024. I'm not going to with the details of other details of this paper, so I'm going to start the paper straight away. Question number 1. The formulas of the molecules A to I are shown in table 1.1. A C2H4, B C2H5OH, C CO, D CO2, E Cl2, F NO2, G N2, H O2, I SO2. Answer the following questions about the molecules A to I. Each letter may be used once, more than once, or not at all. State which of the molecules A to I, A, is an element with a triple bond. Now they are saying an element with a triple bond. We have elements Cl2, N2, and O2. Chlorine is in group 7, is chlorine. It needs 1 electron to complete its valence shell. Oxygen is O, it's in group 6. It needs 2 electrons to complete its valence shell. Nitrogen is in group 5. It needs 3 electrons to complete its valence shell. So chlorine needing 1 electron to complete its valence shell, so it will definitely form single bond like this. Two chlorine atoms will form single bond like this. I'm showing the one pair of electrons which are shared between these two chlorine atoms. For nitrogen, both need 3 electrons to complete their valence shell, so both will share 3 electrons. So they are going to form N triple bond N. What about oxygen? Oxygen group 6, they need 2 electrons, so they will share 2 electrons coming from each atom, so they will form O double bond O. So it must be having G as the correct answer for part A. B is a product of photosynthesis. During photosynthesis, the products are glucose and oxygen. So here oxygen is given, so I will write H. Part C is used as a fuel. If you look at the list, we have ethanol in the list. This is ethanol. And this is also used as a fuel in racing cars. So you write B for C. D turns lime water milky. We all know that's carbon dioxide. D. So I'll write D here. Part E undergoes a substitution reaction with alkanes. Now, alkanes undergo substitution reaction in the presence of ultraviolet light with halogens. So we have one halogen here, which is Cl2. So it must be E. F is a colorless liquid at RTP. RTP is room temperature pressure. See, so we are having only one liquid in this list, and that is ethanol. It's a colorless liquid at RTP. So B will be the final answer for this one. G is unsaturated. If you look at the list, we have ethene here, which is unsaturated, contains carbon-carbon double bond. So the answer must be A for this one. H is 21% of clean dry air. You know that oxygen is present in 21% clean dry air. So H must be the right answer for this one. I is a reactant in the Haber process. In Haber process, we have nitrogen and hydrogen as reactants. So we have nitrogen here. So G must be the right answer for this part. Moving to next question, which is question number 2. Aluminium is manufactured by the electrolysis of aluminum oxide. A. State the name of the main ore of aluminium. It's learning by heart. So we have ore bauxite. So I will write bauxite here. Part B. Name the substance mixed with aluminium oxide to reduce the operating temperature of the process. It's cryolite. It's used to reduce the melting point or acting as a solvent or reduce the operating temperature of the process. C. Explain why the molten mixture in B conducts electricity. It's due to the presence of the mobile ions. So a liquid conducting electricity must have mobile ions in them. Part D, table 2.1 contains some information about the processes which take place at the anode and at the cathode. Table 2.1. Only anode reaction is given. Number 1, complete table 2.1. They are asking about the reaction which takes place at cathode. You know, at cathode, aluminum 3+ ion moves and gain 3 electrons. So I will write Al 3+ 3 electrons gives Al. At anode, the reaction is incomplete. So there's a loss of electron, which means oxidation is taking place at anode. And we have oxygen on the reactant side, which carries 2- charge. And there are 2 moles of O2-, which means there will be 4 electrons. So I will write 4 here. Number 2, state why the process at the anode is an oxidation. There's a loss of electrons. So you write loss of electrons. That's why it's an oxidation. Number 3, oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide, not oxygen. Now, see, anode, it's made up of carbon or graphite. And due to the high operating temperature, this oxygen produced, it reacts with carbon, or carbon burns. You can even write combust in oxygen. Combust means it's reacting with oxygen. So first of all, you write, so 2 marks. So you write anode is made of carbon or graphite. So then anode reacts with oxygen. You can even write burns or combust. E, state why aluminum is used in food containers. It does not corrode, it's resistant to corrosion. So you write aluminum is resistant to corrosion. Part F, aluminum reacts with fluorine to form the ionic compound aluminum fluoride. Complete the dot and cross diagram in figure 2.1 of the ions in aluminum fluoride. Give the charges on the ions. So first of all, we need to complete the dot and cross diagram of the ions in aluminum fluoride. So aluminum, where's aluminum? Here's aluminum, it's in group 3. And group 3 is a metal. It will form +3 ions by losing 3 electrons. And fluorine, the other element is fluorine, which is in group 7. Here's fluorine. They need 1 electron to complete their valence shell to form minus ion. So aluminum will lose 3 of its valence electrons and it will be left with 10 electrons. And fluorine will take up those electrons. So aluminum, there will be 10 electrons left. So 2 electrons, they have already shown 2 electrons. So I'm going to show the other 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now it has lost 3 electrons, so I will write +3 here. The ion which will lose 3 electrons, it will form +3 ion, also known as cation. Fluorine, each fluorine atom will take up these electrons or gain electrons to form negative charge ions. So they have 9 electrons, each of these having 9 electrons. After gaining 1 electron, it becomes 10 electrons. So 2 electrons are already shown. I need to show the other 8 electrons. Remember, 1 electron must be from aluminum. So I will use cross for this 1 electron. Now show these 7 valence electrons of fluorine. 1, 2, 3, 4, 5, 6, 7. And it will carry minus charge. In the same way, you're going to show the valence electron for the other fluorine atoms along with the charges. Moving to next part, which is next question, which is question number 3. Sulfur forms 2 chlorides, P and Q. Chloride P has a formula S2Cl2 and chloride Q has a formula SCl2. A. Both chlorides are covalently bonded and have low melting points. Suggest in terms of attraction between particles why these chlorides have low melting points. There must be weak attraction between the molecules because they are covalently bonded. So we write weak attraction between the molecules. Part B, chloride P, S2Cl2 forms when sulfur reacts with chlorine. Write the symbol equation for this reaction. We know the symbol for sulfur, it's S, and chlorine is in group 7. It exists in the diatomic state, so I will write Cl2. Formula for P is given, which is S2Cl2. Now let's balance this equation. I need to just put 2 before S. Now this equation is balanced. Part C. Complete the dot and cross diagram in figure 3.1 of a molecule of chloride QSCl2. Show outer electrons only. You need to show only the outer electrons. Now let's look at the position of these 2 elements in the periodic table. Here is chlorine and here is sulfur. Sulfur having 6 valence electrons, chlorine having 7 valence electrons, which means sulfur needs 2 electrons to complete its valence shell, while each chlorine atom needing 1 electron to complete their valence shell. So I'm going to show the key on the right hand side for each of these. For sulfur, I'm using cross, and for chlorine, I'm using dot. So for sulfur, I need to show 6 valence electrons. 2 of these valence electrons will be shared with each chlorine atom. Here's 1, 2, 3, 4, 5, 6. I'm done with the valence electrons of sulfur. Now, let's show the valence electrons of chlorine. They will be having 7 valence electrons. 1 electron will be shared with each sulfur atom. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So in this way, you're going to draw the dot and cross diagram for SCl2. Moving to next part, which is part D. Chloride P is converted to chloride Q by reaction with chlorine in a closed system. The reversible reaction reaches an equilibrium. On the left hand side, we have reactants S2Cl2 plus Cl2, and on the right hand side, which is the product, we have 2 moles of SCl2. The forward reaction is isothermic, which means in the forward direction, the value of delta H must be minus, and automatically the reverse direction, it will be positive. Suggest 2 changes to the conditions which will result in a decrease in the concentration of chloride Q at equilibrium. Now I want to decrease the concentration of chloride Q. One of the possibilities is that you can increase the temperature, because this will shift the equilibrium to the reactant side or in the left hand side, because reactant side is endothermic. So you can write any 2 from these. Increase the temperature. Or what else you can do? If you look at the moles of gases, we have gases on left hand side as well as on the right hand side. So on the reactant side, we are having 1 plus 1. On the right hand side, so on the left hand side, we have 2 moles. So on the right hand side, we are again having 2 moles. So it means we are having same moles of a molecule of gases on both sides of the equation. So the effect will be zero, no effect in the change in the pressure. What else we can do? We can even decrease the concentration of T, or you can mention the name of the reactants. Decrease in concentration of P or S2, Cl2 or Cl2 or both. This will result decrease in the concentration of chloride Q, because this will shift the equilibrium to left hand side. E. The rate of the forward reaction in D is determined by collision theory. The rate of reaction depends upon two factors: the frequency of collision between particles, the proportion of collisions which have energy greater than or equal to the activation energy. 1. Define the term activation energy. It's the minimum energy that colliding particles must have to react. The minimum energy that colliding particles must have to react. Number 2, give the symbol for activation energy. Activation energy is represented by EA, capital E, A, small a. Number 1. Number 3, complete table 3.1 to show the effect, if any, when the conditions are changed. Use only the words increases, decreases, or no change. Now it's related to the rate, it's not related to the reversible reaction at dynamic equilibrium state. So you can easily answer these. So if you'll increase the concentration of chlorine, chlorine is on the reactant side, what will be the effect on the frequency of collision between particles? Definitely it will increase. So we'll write increases. What about the effect on the proportion of collision which have energy greater than or equal to? You are only increasing the concentration, you are not increasing the energy. So it has no change or no effect. So you write no change here. You can use no change. Don't write no effect, because they have already mentioned use only the words increases, decreases, or no change. Temperature is increased. Now, temperature increase, it will definitely increase the effect on the frequency of collision as well as effect on the proportion of collisions. So you'll write increases, increases. What about the last one? When you are adding catalyst, it will also increase the proportion of collision between which have energy greater than or equal to the activation energy. So you'll write increases.